Now let's deep dive into advanced package management techniques in Ubuntu. We're going to explore managing package dependencies, fixing broken packages, and cleaning up your system to maintain a healthy and efficient Ubuntu environment. Managing package dependencies. For example, we are going to use GIMP, which stands for GNU Image Manipulation Program, is a free and open-source image editor. It is widely used for tasks such as photo retouching, image composition, and image authoring. GIMP offers a broad range of features that make it a powerful alternative to premium image editing software like Adobe Photoshop. Well, understanding package dependencies in Linux systems. In the world of Linux systems, package dependencies are a fundamental concept essential for maintaining a smooth and efficient operating environment. Essentially, a package dependency refers to a relationship where a software package requires other packages to be installed and functioning correctly in order to operate. Imagine a scenario where you're installing a complex application like GIMP, a graphic editing tool. This application does not work in isolation. It relies on various libraries, utilities, and sometimes even other applications, which are its dependencies. When you issue a command like sudo apt-get install GIMP, the package manager does not just install GIMP, it first checks for all these dependencies. If any are missing, it automatically fetches and installs them too. This automated handling of dependencies is a cornerstone of Linux package management, ensuring that users do not have to manually track and install each required component. In a typical Linux environment, encountering broken package installations is not uncommon, particularly during extensive updates or when experimenting with new software. Imagine you're trying to install a complex application like GIMP on your Ubuntu system, but the installation process gets interrupted unexpectedly, maybe due to a power outage, a system crash, or even an accidental termination of the installation process. This interruption can leave the GIMP package in a partially installed or broken state, which in turn can lead to dependency issues. When a package installation is incomplete, it often fails to properly register the necessary dependencies, leading to a scenario where these dependencies are either partially installed or not installed at all. This situation can cause not just the primary application, in this case GIMP, to malfunction, but it can also affect other applications that rely on the same dependencies. To resolve such issues, Linux systems have robust tools like sudo apt-get install --fix broken. When you run this command, the package manager, apt in Ubuntu, scans the system for broken or partially installed packages and attempts to repair them. It does this by completing any pending installations, fixing incorrect installations, and ensuring that all the dependencies for the broken packages are properly installed and configured. Next, see how we can simulate in our lab machine all command to fix broken command and package installation. In our lab today, let us attempt to install software and disrupt the process. We'll start by initiating the installation of GIMP using the command sudo apt-get install GIMP. To simulate an interruption, we'll press Ctrl+X on our keyboard, halting the installation midway. This action results in the software not being properly installed. Next, let us verify the state of the installation. We can do this in a couple of ways. First, by using dp-kg-l pipgrep GIMP. We can filter and view the package's status. As demonstrated on my screen, you'll notice that GIMP is only partially installed. Another method is to inspect the system logs by executing cat/var/log/tpkg pipgrep GIMP. We can see messages indicating the status of the package as half-installed due to the interruption. To resolve this half-installed state, which is quite straightforward in Linux, we'll focus on fixing the broken package. The command for this is sudo apt-get install --fix broken. This instructs the system to scan for issues, repair the broken package, complete the installation, and resolve any dependencies. After executing this command, it is good practice to check for any additional dependencies. We do this by running sudo apt-get-f install. This command ensures all dependencies are accounted for, as indicated by messages on the screen stating what is missing or confirming that no additional updates are needed. Once we've addressed these issues, we proceed to reinstall GIMP by typing sudo apt-get install GIMP again. This will display the installation process, and upon completion, GIMP should be fully installed on our system. You'll observe the steps like reading package lists and building a dependency tree being successfully executed. Finally, let us verify that GIMP is installed correctly. We can do this in several ways. One method is using the whereis GIMP command, which provides the absolute path of where GIMP is installed. Another way to confirm the installation is by checking the version with GIMP-version. This will display the installed version of GIMP. Additionally, GIMP-help provides various help options, indicating the successful installation of the software. Thank you for joining this practical session. We successfully navigated the process of installing, interrupting, and fixing software installation in Linux. Stay tuned for our next video, where we'll explore more Linux package management techniques.